Hello and welcome to Mystery Science. Today we're going to be looking at the changing atmosphere, and this fits in with our Earth and atmosphere topic that we've been doing. The students at my college have a booklet that they're going to be working along with, and I'm going to make reference to that. If you are not a student at my college, then you can follow along anyway, and you can even do the work if you want to. But in this lesson, we're going to look at air. What is air? What's it made of? Why is air air? We're going to talk about the early Earth. Earth as it was just forming, changing from a ball of molten rock into what we now know today. And we're going to talk about the atmosphere as it was then and how it is now and what's gone in between. But first, I'll do now. The first thing we need to do for every lesson is just remember little bits about what we've done before. So, what is respiration and what is photosynthesis? If you're not sure on either of these, then have a look at my previous video, lesson 4, because I talk about it in that one. Alright, so the first thing we have to understand when we're talking about the atmosphere is we have to define what is air. This stuff around us, when we do this, we can feel the particles of air hitting our hand and brushing against it. And every time I talk about this, I stand in front of a class full of kids who then just sit there staring at their hand, doing this for a while. And it's also a mixture of gases. So when we're feeling these particles hit our hands, it's not just particles of one type of gas. It's actually several different gases. There's oxygen, nitrogen, argon, there's carbon dioxide. There's a whole bunch of other gases. Now, if you look at this table here, it tells you the proportions of gas that are in air. And you'll notice that most of it, just over 77%, 78%, is nitrogen. The oxygen in the air, which is what most people think of when we think of the air, because that's what we breathe to survive, is only 21%. That's just less than a quarter. And then the rest of it is only 1%. So it's a tiny, tiny amount. So in your booklet, you have this pie chart and this table. I want you please to fill in the pie chart. So label the pie chart with each type of gas, which you can do by assigning the largest one with the largest percentage. Okay, so moving straight on to task number 2. If we think about the atmosphere and the air that we currently breathe. Now I've just told you the current composition is about 78% nitrogen, 21% oxygen and 1% others, mostly argon, and carbon dioxide forms a very, very, very tiny amount. So that's fine, that's the atmosphere we have now. The atmosphere very, very early on, though, when the Earth was first formed, was completely different. And in your workbook, you're going to tell me how they're different. And you're going to get that information from this table. Look at this. As the Earth started to form, the gases that formed in the atmosphere was mostly carbon dioxide. 95% of all of the gas in the atmosphere was carbon dioxide. Only 5% was made of other gases. Compare that to now. Carbon dioxide makes up 0.004% of today's atmosphere, compared to 95% back in the day when the Earth was originally formed. So that is a massive decrease. I want you to tell me by how much. And then, can you figure out why wasn't there any life on early Earth? What do we need now that we can get from our atmosphere that we couldn't get then? And again, if you need a hint, go back and have a look at my previous video about the carbon cycle and you might find out. Right, so step into my time machine. Come on, it's fine. We're going to go into the Wayback When machine and we're going to go to the early Earth. Now, the Earth formed by lots of bits of rock colliding together, and every time a massive piece of rock hit, it would just kind of form into this massive molten ball of rock, and all the heavy elements like the iron sank down into the middle, and you've got this just ball of molten rock growing and growing as things hit it. Eventually, as the solar system started to cool down and most of the heat was in the sun, the planets as they were being formed cooled, and so we had this molten ball of rock starting to cool, and we got a thin layer of rock forming on the outside. This is the crust. Now the crust keeps getting disturbed. There's cracks in it. Also, things occasionally will come along and hit it, and this formed volcanoes. And these volcanoes would erupt all of the time, and the early Earth was mostly just volcanoes spewing carbon dioxide and water vapor into the atmosphere. It was like it was just fire. Now again, if you go back and look at my video about the carbon cycle, I talk about combustion and I talk about fire giving out carbon dioxide and water, and that's what was happening here. There was just tons of it being thrown into the atmosphere. So we had a ball of molten rock. On the outside we had this thin layer of rock, and then these cracks forming volcanoes spewing this molten lava into the onto the crust, but also spewing out carbon dioxide and water vapor at the same time. So we're starting to now form a layer of gas around our planet. Now, we had huge clouds of water vapor that were being spewed out of these volcanoes. Eventually, as the Earth cooled even more, this fell as rain. And I'm not just talking a little bit of rain. Oh no. And, you know, we live in Devon, or at least the college I'm in is in Devon. We see a lot of rain here. And yeah, this was rain. It rained for years and years. All of the water vapor in the sky fell and formed oceans. This is where the oceans come from. It rained so much that it formed the oceans. But still, the atmosphere is all carbon dioxide pretty much. There is no oxygen. So we're having trouble breathing unless we're wearing some oxygen tanks. Alright, on to task number 3. Here is a diagram of a volcano. Now, imagine that this is a volcano, part of a massive chain of huge mega volcanoes that form part of the crust of the early Earth, constantly erupting, forming new bits of land as the lava cooled, making igneous rocks, but it's spewing all of these gases out. So I want you to try and label these empty boxes using these words down below. We've got ammonia, carbon dioxide, condensed to form oceans, methane, nitrogen, and water vapor. Okay, so these words need to go somewhere in these boxes. Okay, so here we go. Here's our volcano, and it is giving out a lot of carbon dioxide that's being released into the atmosphere, but it's also releasing a lot of water vapor. Now that water vapor eventually condensed to make liquid water, and that fell from the sky and made oceans and seas. Small amounts of methane, nitrogen and ammonia were also seeping out of the volcano, so we had some other gases in the atmosphere as well, but mostly carbon dioxide. 95% of the gas releasing from this volcano was CO2, carbon dioxide. Now, our atmosphere today, thankfully, is very different. If we still had that same atmosphere, we wouldn't be able to breathe. Carbon dioxide is not very useful to us, so we'd suffocate and die, and all life wouldn't exist. All life needs to respire. If we think about our life processes, Mrs. Gren, they need to respire. So without respiration, without taking in oxygen and giving off carbon dioxide, then all life on Earth would die. So we need oxygen. Thankfully, though, in today's atmosphere, we have quite a lot of it. 21% of the atmosphere is oxygen. And that's quite good because there's quite a lot of atmosphere knocking about. There's a lot less carbon dioxide today, a lot less. We're talking 0.0004%, which is a tiny amount. And even though it rains and there's clouds in the sky, there is a lot less water vapor than there was in the early atmosphere. So the water vapor, as the Earth cooled, stopped being so violently volcanic. The water fell from the sky, condensed, formed the oceans. So we have masses and masses of water falling from the sky. So if you can imagine, try and imagine the clouds beforehand. So you had all this carbon dioxide in the atmosphere and just huge clouds that just constantly was in the air, and it was too warm to fall as rain. And then eventually, as the Earth cooled, got cooler and cooler, that rain fell, and so much water fell that we've got the oceans. And in fact, 70% of the world as we know it now is ocean. Now, we can't be sure where life first began in the oceans, but we can imagine that they started out as single-celled organisms, things like amoeba and bacteria, and these eventually developed and grew all the kind of organelles that we know of today for cells. Now, some bacteria developed and evolved to be able to photosynthesize. These are called cyanobacteria. Now, photosynthesis is taking in carbon dioxide and water and using it to make glucose, a store of energy. But as well as that, it produces oxygen. So as these things spread in the ocean, the carbon dioxide in the atmosphere was starting to dissolve into the water, but was starting to get used up by these cyanobacteria, which were giving off oxygen. Now, when there was more and more oxygen, that meant that life could develop even further, and the organisms are now able to give off more and more oxygen. So now we think that plant life started to develop, and so plants are well known for photosynthesizing. They use sunlight to take in taking in carbon dioxide and water and converting that into a store of energy and glucose and giving off oxygen. So as more and more of this life developed, oxygen began to be pumped into the atmosphere, and this means that as the oxygen levels increase, life can become more complex, and as life gets more complex, this process goes on, and so we've got this chain reaction of oxygen increasing in our atmosphere, and also this helps decrease the levels of carbon dioxide. Now, the carbon dioxide is now able to be dissolved into the sea. So this new levels of ocean all over the planet is now dissolving the carbon dioxide from the atmosphere, and all of the new plant life and cyanobacteria and things that were photosynthesizing were also taking in the carbon dioxide and giving out oxygen. So the levels of carbon dioxide over millions and millions of years is decreasing, and the levels of oxygen are increasing. Now, this means that the carbon dioxide is going down, the oxygen is going up, and it means we can support more life. So life develops. As life develops, the atmosphere changes. Life has always changed the atmosphere. of some of the carbon dioxide, when it's dissolved into oceans, can be turned into shells, into other other carbon-based compounds. And this means that more sea creatures can develop, they have more protection, they have more space, they have places to store food, they're able to move around in different ways, and this again allows more carbon dioxide to be dissolved into the ocean. So if you think about this, and our last lesson about the carbon cycle, the more complex life gets, the more carbon is being locked into the bodies of the organisms. And so the carbon dioxide levels are reducing, and again the oxygen levels are increasing, makes more life, more complex organisms, locking more carbon into the bodies of the more complex organisms. And so it goes on, and we eventually get to where we are today. Now what I'd like you to do, I'd like to challenge you to become the teacher. I want you to try and explain this to a year 6 student. So I want you to write in your workbook why oxygen is present today, and why is there less carbon dioxide than the early times, and why there's an awful lot less water vapor. So I'd like you to explain that to a student from year 6. Imagine you're going to try and tell a younger sibling how the atmosphere has changed over time. Okay, here are your progress questions to end the lesson. Number 1, what element forms most of the Earth's atmosphere today? Number 2, where were the gases that formed the Earth's early atmosphere released from? Number 3, what 2 compounds are thought to have formed most of the Earth's early atmosphere? And then number 4, which element that makes up about 21% of the atmosphere of Earth today was not thought to be present in the atmosphere 4.5 billion years ago? So if you don't know the answer to any of those, go back through the video a little bit and watch through it again so that you can work out the answers to these questions. All right, stay safe, and I will see you soon.